We can extend this idea of square roots to algebraic expressions, but we have to consider one detail we haven't looked at so far, and that is the square root of a negative. There is no number in the real numbers that when multiplied by itself gives us -9. This is because if you multiply a positive times a positive, you get a positive. And if you multiply a negative times a negative, you get a positive. So we can't multiply a number by itself and get -9. So we can't have square roots of negative numbers and expect to get answers that lie in the real numbers. Notice that we run into this difficulty if we start considering things like the square root of x. Because x is a variable that stands for some value, but we don't know what x is. X could be positive or x could be negative. If x stands for a negative value, then right here we are indeed taking the square root of a negative number. So, to start off with simple problems for this lesson, we will assume that all algebraic expressions are positive. So, that being the case, if we look at the square root of x squared, then we're asking what do we multiply by itself to get x squared, and the answer is x, because x times x is equal to x squared. Likewise, the square root of 16x squared would be equal to 4x, because 4x times 4x is equal to 16x squared. Here we find ourselves taking the square root of a polynomial, and this is not too bad either. The answer ends up being x plus 1. How do we know that the answer is x plus 1? Well, if we factor x squared plus 2x plus 1, we get x plus 1 times x plus 1, which equals x squared plus 2x plus 1. Therefore, x plus 1 is the thing that you multiply by itself to get x squared plus 2x plus 1. Therefore, x plus 1 is the square root of x squared plus 2x plus 1.